Hello, my name is Melanie Douglas, and this is my Lab 4 video for oscillations. And so the purpose of this lab is to predict the motion of a specific spring using code. And so here is the fundamental principles, which is the energy principle right here, which is the main one is delta E, the change in energy is equal to the work plus Q. And it's going through potential energy, so both gravitational and spring. And then also it uses kinetic energy. And then we're also going to be using Newton's second law. And then the system is defined as the spring, mass, and earth, and there is no external surroundings. So there's no external work being done on the video. On the mass. So here is our tracker video. You can see here I'm just using the base one that they provided for us. So here you can see the graph right here is a change in x, which is kind of like the sinusoidal wave, and then the change in the y position over time. And so that is our video. And moving on to our code, I am just going to run this code again. So I'm going to load our file. And so you see here, the red I'm pretty sure is the predicted one, and then the blue is, or the blue is predicted, the red is the actual from the video. And you see here is a change in energy right here, and then the x and y positions are pretty much matching, except for the y is kind of like shifted a bit because of this, so you can kind of like tell the difference between both the red and the blue spheres. So going on to our code, don't mind that error right there. So right here we are first defining our ball's mass, which is given to us, and then the ball's initial position and velocity was found through our tracker video. Velocity was 0 and position was this. Okay, going down to here, we are defining our constants. So our first constant is our gravitational acceleration constant, which is 9.8, and then our spring constant, which was calculated from our video, which was around 6.87, and then our relaxed spring length, which was also found from our video, was 0.123. And then we are then going to find L and L hat. So L is defined as the ball's position minus the spring's position, and L hat is pretty much just the direction of that. So we have that, and then S is equals to the magnitude of L minus the initial L. So yeah, and then here is our energy principle thing, calculations. So here we are calculating the kinetic energy, here calculating the gravitational potential, here's the spring potential, and here's the total energy. So going down to here, we are defining both our force of gravity and force of spring, and then we're calculating the net force right here, and that net force is going to be used in Newton's second law to find both the velocity and the position. And then now here we are finding the doing the little spring calculation for the force. So it's pretty much the same thing that we did up there. Yeah. And then here is the energy principle. So here's the kinetic energy, changing kinetic energy, so on and so forth. So with gravitational potential, and then spring potential, and here is the total energy, and here's the change in the total energy. So yeah, that's pretty much it. And you see our code again. Yeah, it changes similarly. Thank you.